Let us continue our discussion on properties of the salt. So in this video, we are going to discuss about what are drying agent. What are drying agent? So as in previous video for an hygroscopy, we have studied that most of the hygroscopic substances have been used as drying agent. So the same definition applies here. So there are certain substances which removes moisture from other substances. So hygroscopic substances can be used to dry the gas. So we have drying agent are the substances which are used to remove moisture from the gases or other substance and act as drying agent, or in common they are also known as desiccating agent. Uh, Towards end of this particular video, we are going to discuss what is desiccator and how it has been used. Now, most of hygroscopic substances which are there, they have been employed as drying agent to dry the gases. Okay, so here we have anhydrous CaCl2. Anhydrous CaCl2, it's in white solid which has been acting as a drying agent. So normally this is a diagram for desiccator. This is how the desiccator will look like. It's basically a glass container which has got an glass plate is there with the groovings. On that I'm putting a sample which has to be dried, and below that particular grooving I'm keeping anhydrous CaCl2 which will act as drying agent. So the sample which is to be dried is kept in this desiccator, and a lid has been put on that and keep it aside for 1 or 2 hours. Later on, when we take out the lid, we can see the sample has become dry. So this is your desiccating agent. This is known as desiccating agent. Now, which are the examples of drying agent? So we have anhydrous CaCl2 that will act as a drying agent, concentrated sulfuric acid. Now this is generally used to dry carbon dioxide and hydrogen chloride gas because it's acidic in nature. Then we have phosphorus pentoxide P2O5, quicklime, calcium oxide that acts as a drying agent. Silica gel. This also we have seen in our previous video where we have the packet containing silica gel has been kept in capsule bottles so as to keep the air trapped in the plastic bottle or capsule bottle dry, so the moisture can be eliminated. Then we use alcohol, so more or less we use ethanol as a drying agent to dry the substances. Now these are the few examples how we can use the drying agent typical. So I have a gas containing moisture. I have a gas containing moisture. So let me take an example here. That is your moist HCl gas. That is moist HCl gas has been passed through concentrated sulfuric acid. Concentrated sulfuric acid. So this concentrated sulfuric acid absorbs moisture from gas, okay, and sets the dry hydrogen chloride gas free. So that has been collected over here. So here concentrated sulfuric acid acts as a drying agent, and it is a liquid drying agent. Now I have another example. Let us consider a moist gas, that is an ammonia, NH3. Now this has been passed through a tower containing calcium oxide. Typical as an example, see here I am taking ammonia as an example. So ammonia is dried using quicklime, using quicklime as a drying agent, okay, to dry the gas, because ammonia is basic quicklime is also basic, so no reaction takes place. So here I am using calcium oxide or quicklime to dry the ammonia gas. So here I am having ammonia, which is dry. Now in this particular case, normally whenever drying, I'm not using other drying agents because they chemically combine with ammonia. So to dry ammonia gas, P2O5 or CaCl2 anhydrous cannot be used as they chemically combine with ammonia. Okay, so I cannot use it. So in this particular case, I am using calcium oxide. So calcium oxide is used to dry ammonia gas as NH3 is base and CaO is basic in nature. Here base I means basic in nature. Okay, so as both are basic in nature, so no chemical combination takes place between them. That's why I use calcium oxide to dry an ammonia gas. Thank you for watching.